Hi, and welcome to our talk on computer science communities, who is speaking and who is listening to the women. My name's Leins, and I'm here with two of my colleagues, Dr. Mark Cheong and Dr. Simon Coghlan, who you'll hear from in just a moment. And we wanted to talk to you about our paper today. It's a little bit different from some of the other papers in that we used some automated tools to look at representation in different communities. And we want to just talk a little bit about how we did that, why we did that, and what that means in terms of our messaging and what we think the computer science community should be doing. Thanks for joining us today. Well, we wanted to start, first of all, with an acknowledgement of country. The three of us are on the lands of the Wurundjeri people, who have been the custodians of this land for thousands of years. Interestingly, this introduction has relevance to our work, as many of the stories of the Indigenous people are forgotten or remain untold. There are many things that we don't see, and part of that is the theme of our work. Just so you know what the three of us look like, or at least in better times pre-COVID. These are my colleagues again. First of all, I'm going to speak briefly to the background, literature and motivation in this project. Mark is going to speak to the empirical methodology, and Simon is going to speak about the ethics of care recommendations that we've made in the paper. The background. The background to this paper was fairly simple. An increasing body of work is starting to investigate areas of science that have been underlooked or overlooked and underconsidered. One of those areas is particularly in relation to birdsong, and a piece that I read struck my interest, or piqued my interest, because it was about something so obvious, female bird singing, and yet for many decades it had never been researched, and in fact the men doing the research had said that female birds just don't sing. Some recent research by Casey and her colleagues found that female birds do in fact sing, but they'd never really been considered as singing. And this was a really interesting example for me of how diversity in the research itself was bringing about quite different research, and arguably, and as we argue in our paper, a much better quality of research. The same could be said for some other areas of work. Even research into the human anatomy has shown that up until 1998, there was not an accurate description of female genitalia. This is a particular example, but it's a really interesting one to use. As a woman, I found it really interesting that I had actually never seen one until some of this research was undertaken. I also found it really interesting from the perspective of thinking about other groups of people and other pieces of information that I don't have or things I don't see. I think we need to consider who we're including in our conversations to think about how we can have better research, and that is across the board for all areas of computer science. This is one of the first types of photographs ever taken, and it's called a Daguerreotype, named after Daguerre, who took the first photo. In fact, this is a thriving street in Paris in the 1800s. But if you look closely, all you can see is one person. That one person is standing with their foot up on a rest, having their shoes polished. And the reason you can see them is that everybody else is moving, and this type of photography didn't capture movement because it took so long to be exposed. In so many ways, so much of the research that we're doing is like this photo. We only look for certain pieces of information, or we capture information in ways that exclude many people who are key to the stories that we should be telling. And in this piece, the goal of this research was an initial foray into trying to explore the hypothesis that without that diversity in the room, we can't actually have good research. And to talk about how we took the first steps in doing this research, I'm going to hand over to my excellent colleague, Dr. Mark Cheong. But before I hand over to my colleague, I just wanted to add one more point, and that is this paper, although we've written about it in a way that's about gender, is not just about gender. In fact, it's about so much more. It's about including all of the groups that are currently not included in computer science. It's about not having just one individual loud voice, but including the voices of many people. And for me personally, that's an issue not just of gender, but also of demographic. Neither of my parents went to university. There are many different ways in which we can feel different or be other, and our journeys are each individual and different. And what we are trying to capture in this paper is not that one should be preferenced over another or that one is more important than the other, but what we are trying to focus on is really how important it is that we include all of those voices. And as my colleague Simon will argue, that there's actually a duty of care. So although we've used a very blunt instrument of automation, which we don't intend to use again, and we have put in our paper a number of disclaimers explaining that gender is not binary, gender is complicated, we are not just talking about gender. What we are trying to do is make a foray into this community to start talking about the diversity that we need to see, and that expands well beyond gender to demographics, to race, and to every other way in which we can feel othered or minoritized. On that note, I'm going to hand over to my colleague, Mark. Thanks, Mark.
Hi, everyone. I'm Mark Cheong from the University of Melbourne, and thanks to Dr. Leins for her excellent introduction and the background to our research. So we have four main research questions. Firstly, how are female academics currently represented in publishing in each of the subfields of computer science? And the second research question is an interesting one because in this part of the research, we consider computer science to be a monolith comprising of many unique subfields. It's not just, for example, diversity in computing that we're trying to improve, but in each of the subfields. And unfortunately, based on current statistics, some of these subfields have slightly better representation than others in terms of diversity. And after that, I'll pass on to my colleague, Simon Coghlan, for the third and final research questions on, for example, what might care ethics have to say about underrepresentation of women and other minoritized groups in computer science and its various subfields? And finally, actions and recommendations us as a community as a whole can take to reduce disparity and hopefully pave the way to a better future for future generations of scholars and researchers. So towards answering the first couple of research questions, let me focus on the empirical methodology used, bearing in mind that these methodologies have been used in other papers before. Again, as my colleague Kobe mentioned before, this is just a starting point to start discussion by getting an empirical investigation into the issue of diversity we're facing. And we're very grateful to our colleagues and also the University of Melbourne Ally Network for their feedback on how we chose to approach this and basically issues and things we have to address up front. First of all, this also highlights one of the other issues of, for example, the artifacts of computing technology. So, for example, if we have certain inference libraries or services to detect male-sounding and female-sounding names from, let's say, author publication records, they might also have poor performance in, for example, correctly analyzing names of diverse multicultural names, for example, because the current technologies are trained on a more Anglophone context. And again, part of our research wants to highlight that there needs to be diversity, not just female representation, but also other minoritized groups as well. So a quick recap of the methods and limitations we have in our project. So based on current publication records in academic citation databases, which is an approach that many existing pieces of research draw upon, and the work by Santa Maria and Mihaljevic, who had a good literature review on the ethics, the considerations, and the technological limitations of algorithms to infer gender from names of authors. So from earlier trials, as we mentioned before, just using one of the libraries is suboptimal because it's more Anglo-centric. It doesn't capture the diversity in terms of, like I said, multicultural names, and this illustrates further issues up front. So humanistic approaches always remain the gold standard. For example, interviews, asking people for their preferred gender marker, having participant observation, that's the gold standard that we would hopefully do in future work, which we'll cover towards the end of the presentation. So the data set we use is from Microsoft Academic. As a data source, we have metadata provided for each paper we consulted. So we surveyed 9 subfields of computer science, AI, computer science as in theoretical computer science, computer security or information security, computer vision, human-computer interaction, information systems, machine learning, NLP, and systems architecture. Those are common research focus areas in top universities. We have done through a quick exploratory analysis for example, the group of 8 universities in Australia and also the top universities in the US as well. And we settled on these 9 subfields of computer science for our inquiry. A total of 20,000 citation records from 9 subfields. After you've done data cleaning and deduplication and breaking ties, for example, if a paper is classified under dual subfields, we just break ties by taking the first one. We end up with n equals to 150,651 citations. That's what we're working with. And for each citation, we obtain the author names and we process using the Python gender guesser library as well as genderize.io. And after that's done, again, we are obtaining statistics as a whole aggregate for a subfield, and we do not identify or pinpoint individual authors or contributions towards a paper. And Also, one consideration we have is we do not remove duplicated names across papers. So, for example, if a hypothetical author, Shanti Kumar, was present across 3 papers, we found 3 separate instances, do not dilute the contribution of a single author. That takes into consideration, for example, someone who's contributed to various topics, for instance, throughout their academic life. They might have started their PhD in a certain field, then moved to another field, for instance. In my case, I started off being a computer scientist, now working in computer ethics. And the results are, firstly, there are 2 sets of results. The first set of results on the left indicate the gender distribution of authors, so by male-sounding and female-sounding names, including gender-neutral names and names which are undetected. So, for example, if someone's name is from a culturally diverse group and those algorithms have not seen the name before, and therefore it would not be able to statistically infer like if it's a male-sounding or female-sounding name. But if we just compare the results from the male-sounding and the female-sounding names, we find out that we have the results on the right, which is basically illustrative of the gender gap in current subfields of computer science. And this is statistically significant with an ANOVA test with alpha 0.05 in Microsoft Excel. And you can see that in the figure to the right, there are some subfields which have slightly better representation of females than other subfields. So, for example, we can see natural language processing and HCI information systems are slightly higher on average. But that's, again, not the future we want. We want a future where there's equal representation of every group, every minoritized group. So I'll just briefly run through the empirical results we have before passing to my colleague Simon. So you have 2 groups, as mentioned before, a slight improvement in NLP, information systems, and HCI, and the rest are in the less gender diverse category. So we start off with a rough 3-to-1 ratio in the category of slight improvement. So, for example, HCI, we draw upon work by, for example, Amaka and Buchanan, who have published in terms of representation of women in HCI, and also an NLP where we hypothesize based on the work by Levy, because issues such as language bias in language models affect those who are, for example, in minoritized groups, for example, female computer science researchers in NLP. Therefore, they're taking proactive steps to understand and attempt to resolve it. The full quote is but slide for our paper as well. And in the realm of information systems, again, the products or the artifacts generated by work in these subfields are actually affecting people in large scale. For example, think of search engines. They might have started off being a way to organize information systems, just to index them and provide relevant information. But as you might have known from issues covered by the book Algorithms of Oppression, these artifacts themselves affect minoritized groups. So those researchers in these disciplines are more positioned to look at these issues and try to understand and resolve these issues. But for example, for AI, theoretical computer science, information security, machine learning, computer vision, one hypothesis we have is the high emphasis on mathematical and scientific techniques consequently reinforce historical biases. So in our paper, for example, we cover issues where these subfields are treated as a more scientific endeavor, which attracts more males to it, and therefore unfortunately, the cycle continues unless we can break the cycle in the not too distant future. So how do we fix it? Now I turn to my colleague Simon Coghlan on a treatise from the Ethics of Care and why the ethics of care is in a good position to address these issues, but more importantly, the recommendations for us as a discipline to rectify these in future.
Thank you very, very much, Dr. Mark Cheong. My name is Simon Coghlan, and I'm going to present the final part of this presentation, which is to explain how an ethics of care might help us in interpreting our results and in offering some recommendations. So just a brief bit of background first on the ethics of care or care ethics. Care ethics is one way in which you can make sense of the findings that that women have been underrepresented in computing science communities. Care ethics is a relatively new approach to ethics compared to some of the older forms of moral theorizing that go back 2,000 years. And care ethics arose from the 1970s and the 1980s from feminist modes of thought, which criticized male-dominated philosophical attitudes and ways of thinking, and particularly arose from the work of the psychologist Carol Gilligan and her famous book, In a Different Voice. So this emerging care ethics approach criticized dominant conceptions of the moral agent, the moral thinker and actor, as being entirely independent, self-sufficient, unemotional, and rationalistic in their behavior. This approach criticized the notion that morality is about applying unvarying moral rules and principles to situations. And it suggested that rather than doing that, we look at the contextual and relational aspects of our moral lives. And through this approach, care ethicists developed a form of moral thinking and theorizing which prioritized responses like attentiveness, responsiveness, compassion, and a recognition that we are all codependent upon one another. We're all susceptible to various vulnerabilities at different parts of the life cycle. However, there are some groups in society which have been minoritized and which have been oppressed over potentially centuries or longer. And this also applies to groups which have been at the intersection of different forms of oppression. So while our particular project is focused on women, we also want to say that these kind of results can also apply to other minoritized and historically oppressed and ongoing oppressed groups, such as LGBTQIA+ communities, various racial groups, religious groups, older people, and disabled people, as well as others. So care ethics arises from a recognition of the relationships that we have with one another, close caring relationships. However, there are relationships that we have with people who are more distant as well. And so there are elements of care ethics that can accommodate notions of justice. Some care responsibilities that we have extend to our academic colleagues and to our students if we're academics. But care ethics can also accommodate and indeed sharpen or deepen our sense of justice towards people more generally, not least towards people who are oppressed or are vulnerable in various acute ways. So within the computing science communities, women, we know, have been subject to various kinds of discrimination, both overt discrimination, but also hidden and unconscious biases, which have sometimes prevented individuals from achieving their wishes and their goals. It appears from our research that underrepresentation of women, at least, is worse in some communities than in others. So, for example, we found that in computer vision, AI, and information security communities, underrepresentation appears to be worse than in other communities. But a care ethics approach requires that we attempt to remedy these injustices for various reasons. One is for the sake of the women who are involved in those communities, and also for future women who may wish to pursue a career in various computing science communities. In addition to that moral requirement of justice, we can also point out that fairer representation also potentially helps to reduce gender bias within those communities, gender bias and discrimination, as well as potentially other forms of discrimination. And more broadly still than that, a recognition of our duties to vulnerable and oppressed people means that we should seek to address prejudice and bias both in those communities and in the products which those communities or those various disciplines produce, in order to minimize the harmful effects of those products or forms of using computing technologies on the broader society. So I think these computing communities should see the move towards greater equality and greater representation of minoritized groups more as a threat, more as an opportunity rather than as a threat, because it has the potential to improve the quality of the work which is done by those disciplines. And that brings us to the final point, which is what recommendations can we draw from our discussion of care ethics and our empirical findings. So care ethics supports the active nurturing of individuals. It also supports changing institutional attitudes and structures which allow injustices to persist. If you have a look at the ACM Code of Ethics, we find the following words. It says that computing professionals should foster fair representation of all people, including those of underrepresented groups. And it also points out that the use of information and technology may cause new or enhance existing inequities, and that computing professionals should take action to avoid creating systems or technologies that disenfranchise or oppress people. And that seems to be in line with the finding with our care ethics approach, which says that we ought to do more and take action to avoid underrepresentation and injustice. So these responsibilities apply both to the computing science communities themselves, the individuals within them, and also to broader groups such as the ACM. In fact, we can draw lessons, I think, of accountability for groups like the ACM from this analysis. And one suggestion we could put forward is that the ACM could monitor compliance with its principles, including the ones I've just outlined, and even set up a dashboard of compliance against which those computing science communities can measure themselves annually and check their progress to see if they're meeting their goals and targets and responsibilities. And finally, the ACM could move beyond an overarching code of practice to develop more specific guidelines, perhaps best practice guidelines for those computing science communities in order to reduce injustice and increase the representation of various minoritized groups within the computing sciences. And that brings this presentation to an end. I want to thank you very much on behalf of my colleagues Mark and Kobe and myself, Simon, for listening to the presentation. Thank you.